In this video, we're going to learn about box plots. So what is a box plot? Well, it's another way to visualize data, visualize information, and it's used to show the spread and variability of data. What we mean by spread and variability, think of it this way. If I told you that if I was talking about the 99-cent store or the Dollar Tree, you can expect that everything at the Dollar Tree costs anywhere between maybe 10 cents and a dollar. So the variability of the price, how much it's the difference between the price isn't very much. It could cost anywhere between 10 and a dollar, 10 cents and a dollar. So that means the difference between the most expensive thing and the cheapest thing would be 90 cents. But if I told you that if we were going to compare it to a place like, I don't know, Target, where maybe the cheapest thing is 25 cents and the most expensive thing is $5,000. That has a much bigger or wider spread. So a box plot can show you, give you an idea of what the spread looks like and how much it changes or how variable it is. It also divides the data into 4 parts using 5 data values shown to the right. So the first data value is the minimum. It's the cheapest, or it's in the case of a store, it might be the cheapest thing at the store. I like to shorten it to min. Sometimes you'll see that for minimum. The second data part, or the second data value, is called the lower quartile, and this sometimes is called the first quartile or first quarter. The second one is called the median. Remember, that's the middle number, and that's the second quartile. Sometimes it's referred to that. And finally, not finally, but the next one is called the upper quartile or the third quartile. And finally, we have the maximum, which is the biggest thing. So if we're referring to the price of things at a store, we would say that the maximum is the highest amount. So if, let's say this was a dollar store, we could say, oh, the cheapest thing is about 35 cents and the most expensive thing is 100 cents. And then the median price of things would be maybe 83 cents or 82 cents, something like that. Finally, the thing with box plots is that each part makes up 25% of the data. So what do we mean by parts? Well, there are 4 parts in between. This is the first part, and this is 25% of the data. So 25% of the products at the Dollar Tree are between 35 cents and about 66 cents. And then we would say 25% of the products are between 66 cents and 81 cents. And then 25% is between 81 cents and 93 cents. And then 25% of the products are between 93 cents and 100 cents. So that's what that means, the 25% of the data. So let's go ahead and go over some examples. How do we make a box plot? Well, we need to find the median first, and then we'll need to find the other value. So we're going to start off with the median. And to find the median, remember, we make sure that everything is in order from least to greatest, and it is from 19, 20, 29, 32, 33, 34, 42, 47, 59. That is the biggest number, and that is the smallest number. So this is the minimum, and this is the maximum. The median is found by crossing off the ends, so one off the left, one off the right, one off the left and the right, the next, and then it looks like this is the only number left. We don't want to cross it off, so this is a median. I like to draw a line through the median. So our median is 33. Okay, so how do we find the first quartile, and the third quartile? Think first quarter, like 25% of the data. 25 is half of 50. So you would think that the first quartile is the middle of the first half, and the third quartile is the middle of the second half. Okay, so let's do the first quartile or the lower quartile first. So what we do is we cross off the ends. And we don't include the 33. We do not include the median. Next, well, that means we've got nothing left in the middle. So we need to find the number between those two, which means we need to find the average. So we add up 23 and 29, divide it by the number of values, which is 2. And that's 52 over 2, which equals 26. So the first quartile is 26. And let's do the third quartile. So it's the middle of the second half. So we're not including the median. We cross off the ends. And then those two, there's nothing, there's no one number. There's actually these two numbers in the middle. So we find the average. 42 plus 47 divided by 2. 89 over 2, which equals 44.5 or 44 and a half. All right, so we have our lower quartile, our median, and our upper quartile. We now need our minimum, which is 19, and our maximum, which is 59. We're ready to start. So we're going to label this. I'm going to go from 10 to 60. And our minimum is 19, so it's roughly over there. First quartile is bigger than 25, so it's going to be right over here. Our median is 33, so it's bigger than 30, smaller than 35, right in the middle. Third quartile is 44.5. That is really, really close to 45, so it's going to be just to the left of it. And finally, our maximum is 59, which is really close to 60, but not quite there, so right behind the 60. We're going to draw a box through the lower quartile and the upper quartile. So it's going to look like that, and it's going to have the median right in the middle. I'm going to draw a line through that, and that indicates the median, the very middle value. And then to make it look like the box plot right up there, I need to draw a line on both sides. And that's it. That's how you draw a box plot, sometimes called a box and whisker plot. Let's try another one. All right, 1, 2, 3, 6, 7, 8, 9, 11. It is in order, so cross off the sides. Next. Looks like we have to cross off both of them. There's no number in the middle. There's no one number. It's those two numbers. So we need to take the number between 6 and 7, which is 6.5. Let's find the lower quartiles and the number in between that goes in between these four. So that gets crossed off. That gets crossed off, which means we need to find the number between 2 and 3, which is 2.5, 2.5. And finally, the upper quartile, let's cross off the ends between 8 and 9, which is 8.5. The minimum is 1. The maximum is 11. So let's start with our, we've numbered it already. Start with our minimum, which is right over there. Our first quartile is 2.5, which is right between 2 and 3. Our median is 6.5, which is between 6 and 7. Our third quartile is 8.5, which is between 8 and 9. Finally, our maximum is at 11, so it should be right above the 11. We're going to draw a box around these quartiles, draw a line through the median, and then draw a line on the side. So 25% of the data is over here, 25% over here, 25% of the data is over here, and 25% of the data is over there. Lastly, let's do this example. Let's start off by finding the median, crossing off the ends, cross off those two number and those two, and it looks like we do have a number in the middle, which is 78. So that's our median. Let's find the first quartile now. So remember, we do not include the median. Oh, something to mention, that we did not include the median when we crossed off the one at the top, if you noticed. We didn't cross off 6.5, it's not there, but we still crossed off the numbers on that side. That's why I like to do this wall instead of some other things. So I'm going to cross off the 66 and the 74, which leaves 68 in the middle. That's our first quartile. And then we're going to cross off 82 and 88, which leaves 85 in the middle. Our minimum is 66. Our maximum is 88. So our numbers are already on the number line. We should have a minimum at 66, 68, something at 78, third quartile at 85, which is between 84 and 86, and maximum at 88, which is right over there. Put our box around this area, which means it's a lot of data in between here, and then, or a lot of variability within this area. Draw the lines on the side. So now you know how to set up a box, or sometimes called a box and whisker plot.